Welcome everybody again. Also, welcome to all the people who joined in the last couple of seconds. My name is Dino Esposito. I'm here today to talk about ASP.NET identity and tools and frameworks and approaches you can find under the umbrella of ASP.NET to implement social authentication, classic Facebook, Twitter, LinkedIn, and so forth. There is a clear transition that is taking place in the ASP.NET space towards a new framework. I have no idea, honestly, when this transition will end. It's started, however. We expect Microsoft to ship probably in April, May, I don't know. Summertime anyway. Version 1. I was told that there should be probably an RC coming out today of Visual Studio 2015 and related frameworks. Anyway, we are really close to some big drops from Microsoft, and regardless of the quality, okay, that we find in Visual Studio 2015, ASP.NET 5, vNext, Linux support, Core.NET framework, and so forth. There is a trend within Microsoft to get rid of a few things of the past. And the few things of the past, as far as the web is concerned, are IIS and the old infrastructure, IIS-based, okay, for ASP.NET. We live in a world that changes frequently at a pace that every 5 or 6 years, okay, let's even every decade, every 10 years, completely, moves things around, and what was right becomes wrong, and what was wrong becomes right. You can remember maybe when, not that many years ago, I think it was around 2007, 2008, maybe 2006, Microsoft pushed out IIS 7, and was all about, all the marketing effort were focused in telling the people how well they did in integrating the IIS runtime with the ASP.NET runtime. There's still a terminology, integrated pipeline, which still we face today when we try to configure an IIS web server. Wow. It's great, it's fantastic, it offers you great performance just because the ASP.NET runtime and the IIS runtime are the same thing, or they work closely together. And today, they are telling us the opposite. What is wrong with ASP.NET is that it's too tightly coupled to IIS. We need to break this dependency. And they introduced OWIN, Open Web Interface, which is a good thing, but serves different purposes. So the point that is trying to, that is critical in my vision of the world, and also in relevance and in connection to this talk, is the fundamental question that, as an architect, as even a an IT manager, has the professional figure responsible for choosing actual technologies for writing code and strategies for doing certain core things in web development, like membership and authentication. The question is, how important is for me have a dependency on IIS? Will I be porting my code in other platforms one day, my server code, my server infrastructure? If I work fine, nicely with IIS today, if I don't feel special concerns, whether performance, whether scalability, with the status quo, with what exists today, most of the things, ASP.NET Identity, OWIN, can be happily ignored, even though OWIN per se is just yet another abstraction layer, more general, that can encapsulate the current IIS as a special case. So in OWIN, Katana, all those keywords that you may have heard and you will hear more and more and more about in the coming days, as soon as new releases of ASP.NET see the light, are things that don't touch directly the way in which we do things. We still need to do authentication, we still need to do authorization, we still need to do membership, we still need to process requests coming via HTTP our way. It's middleware. It's the way in which the runtime, the web runtime, works. And what they're trying to do is making the existing infrastructure, which is essentially a pipeline of steps, begin request up to end request, with a session authentication, with cookie management, with output caching, with authorization and authentication. All these steps in the pipeline will be given a common standard interface, and this essentially makes IIS one possible implementer of these interfaces at the same level of Windows services, console applications, non-Microsoft web servers, and any sort of application of today and tomorrow. Just to say, just to give you a concrete example of what I mean, what we are trying to, what Microsoft is trying to achieve, which was not available for years, for decades, I would say. It was around 2000, so 15 years ago. A company called me to help them building a local web server. It was a different age, so the purpose this company had in 2000 is something that today would make us just laugh, okay? But at the time it was cutting edge, and they needed a super guru to help them out. They wanted to put on a CD-ROM essentially the website. They were a media company. They had a bunch of websites with a lot of information, financial information specifically. They just wanted to put everything as it was a website on a CD-ROM. And to save time, they just wanted to just take the ASP, active server pages, from the website, put on a CD-ROM, and have the CD-ROM work like a website. So the user had to put the CD-ROM in the computer, and automatically they wanted to see some browser to open up and for the user to navigate locally with no internet connection, and the world was the CD-ROM. The problem was just creating a local application that could work like IIS. It was not that hard. We did it, and it was kind of hard because we had to, simulate a lot of things. We had to essentially find a way to inject a scripting engine into the the binary engine we were building to process requests. We simulated that. I guess that today, with an open web interface like OWin, the whole things we did 15 years ago with a lot of effort would come probably much easier. Okay, now, in this talk, you hear about an introduction, role, purposes, motivation, technical details of ASP.NET Identity, the role it plays in the real world. I'm not completely sure everybody needs it, and which are alternatives in case you don't strictly need it. And then how we can, in alternative, outside using ASP.NET Identity, how we can do social authentication via Facebook, Twitter, and similar social networks. In ASP.NET, the whole theme of membership has been a long, long story that probably different teams in Microsoft tried to simplify and cut short at different times, but probably nobody enough successfully. And I just tweeted before starting the session that if I think of authentication today, I believe that it's nearly impossible to build a framework that is universal, supports all possible features of today and tomorrow, so allows you to define the user in whatever way, so with whatever combination of properties you may think of, and with a lot of additional features like two-factor authentication that some sites require and some other may happily ignore. So a universal framework, if it really has to provide support for whatever you can think of today and tomorrow, ends up being significantly complex, and I would say ridiculously complex for doing basic things. So the trade-off, and it's hard to find the right compromise, the right measure, especially if you are a vendor of frameworks, to understand where you have to stop to keep all possible customers, prospective customers especially, happy. So this is the drama, the human drama that we experience, that ASP.NET Identity experiences. It's growing complex every day, and because it gets complex and complex every day, doing simple things that probably the majority of people need to do becomes harder and harder and boring and annoying every day. But this is not a new story. When Microsoft first released the membership framework in the first version of ASP.NET, the classic ASP.NET membership, we could already see some 10 years ago the same problems we can spot today, except that 10 years ago the problems were probably the same in number but smaller in terms of absolute size. So we still had, with a classic membership system, auto-created SQL Server tables, implementing and containing information for users, roles and associations between users and roles. We also had a bunch of server controls for common membership tasks, like the login, change password, reset password, and they made a good job by putting the membership system in the context of a provider-based architecture, meaning that they gave us a base class and told us, okay, this is what we provide out of the box. And if you use our framework out of the box, you must use a bunch of tables with the schema we decided. If you want to change the validation rules, if you want to hash passwords, for example, or if you want to put more logic that controls and makes the detection process of a password more complicated, so detect that the password has numbers and letters and underscores. If you want to, customize some aspects, well, you can do that at the cost of overriding the entire system, creating your own membership provider. It worked. It definitely worked. And it was a nice point because, before ASP.NET, a lot of websites were already, facing the world, and those websites were built without the ASP.NET membership system. So they had their own logic for validation of users. They had their own databases. But yet, because of this non-standard structure, those custom membership systems could not be used and attached to server controls, which were giving all developers a boost in terms of speed of development, because a login page was as simple as just dropping a server control in the page, and everything else was being taken care of by the infrastructure. But with a custom provider, membership provider, you could wrap up your existing infrastructure, your existing database tables, and the standard interface, the custom provider, allowed your existing infrastructure to be connected to the facilities in Visual Studio and server controls. It was not a bad thing. It was working, and it was, complex, but not so complex to scare people. Anything wrong? Just one thing was wrong. And in particular, the fact that the interface of the provider was not really respectful of the I in the SOLID acronym. The SOLID acronym was not known at the time in which Microsoft created the membership system, but SOLID stands for the initials of 5 principles of object-oriented design, S for single responsibility, O for open-close principle, L for the Liskov principle, D for dependency inversion, not injection, and I, the I stands for interface segregation. And the point of I in the SOLID acronym essentially can be summarized with the second bullet point you see on the slide. No client should be forced to depend on methods it doesn't use. So in summary, what was wrong at the design level with the membership provider has defined in the first version of ASP.NET was the fact that the interface of providers were too rich of methods. There were too many things. Too many things defined in a single interface. So the segregation, the split of the partitioning of methods in multiple interfaces didn't happen, but all possible methods, all possible functions, all possible features have been put in a single interface, so that if you wanted to create your own membership provider, you had 15 methods to implement, at least to write throw not implemented exception. But it was not a huge problem yet. I mean, it was boring. I mean, developers faced a sort of conflict. Oh, it's so cool, I can write my existing infrastructure to plug my code and my validation logic in ASP.NET native controls. Let me see how I can do that. Oh, I have to write a class, and then to write that class, you had to override 15 methods, and that was boring. Even 15 methods and 14 just throwing not implemented exception, and just one, the validate method on the membership user class, to just implement the if that checked whether the username was matching and the password was matching. We want something simpler. This is what the people all over the world said. And we got something simpler, but too simple. We got something called the simple membership, coming with web metrics and web pages, which was an attempt to open web development to just everybody, to students, to junior developers, to everybody. So we had, through the simple membership framework, just support for checking credentials. So just a simple, basic check that usernames and passwords were matching. So we had no features like get user, find user, create user, change password, limited support for roles, too simple to be really usable. And in fact, nobody used it. Technically speaking, the simple membership API was based on a new API called Web Security, which contained internally some aspects that survived up until today. In particular, the Web Security API contained an extendable entity model that was over the years attached, connected to the code first feature in Entity Framework. Concretely speaking, it means that now with web security and simple membership, if you define a class that you call this is my user and put in this class a username, password, picture, and any claims, any statement about the user that you need to have available when has information associated with the logged in user, then the call first mechanism in Entity Framework used to persist that data will automatically create a table that reflects the schema of the user class that you provided. So you no longer you needed to create your SQL Server table yourself, but just defining at the C# level the public interface of a class, of a user class, you could have through code first the database being created automatically to reflect and store that specific piece of information. The Web Security API doesn't rely anymore on internal storage procedures, and it was providing the ground for porting storage of the membership information outside SQL Server, and in particular towards local SQL databases and Azure databases. More recently, a couple of years ago, Microsoft decided, okay, we had a membership, the classic membership, which is old and people anyway complains about that. We tried to offer people the simple membership API and they said that it's too simple. Let's sit down and create the perfect identity infrastructure. And they called it ASP.NET Identity, which is a framework centered on an object called User Manager. The User Manager represents the primary interface you work with, okay, when you want to authenticate credentials that a user provided. You interact with this object whenever you want to do anything else, like changing the password of a user, check if a user with a given name exists, check roles, and so forth. The User Manager is a central point, a central console that works with the two other figures, the Authentication Manager and the Store Manager. And the names in this case are self-explanatory. The Authentication Manager is another object that you find exposed as a public member out of the User Manager that takes care of just authentication. So it's the component that checks username and passwords. And the Store Manager is the component that takes care of reading and writing membership information to whatever is the physical persistent store. Default persistence, so by default, if you don't change anything, if you don't configure in a custom way the framework, persistence, the Store Manager, works using code first, an entity framework. So you define a base user class, you put there all the public properties you want to be associated with the user according to what a user is in your development scenario, and code first does the magic of via entity framework creating database tables, appropriate database tables, and read and write out of those. You have to provide a user class, and the user class must inherit from a base class that Microsoft offers as part of the framework. Here is some code. The User Manager class is defined as a generic class that accepts a T-user, and the T-user is the generic type that represents a user, must be a type that implements I-user. And in turn, I-user is the abstraction, the minimal abstraction of a user entity, at least a string ID, at least a string for the username. And this is the absolute minimum you need to have in whatever class you want to treat as a user, but you are welcome to add as many more properties as you like. The overall layout of the framework, so the classes that you are going to have once you set up identity to work. There is a User Manager class of T-user specific for your application, so Application User Manager, which is injected a user class specific of the application. So imagine you derive an application user class from I-user. Then the Application User Manager is injected a user store that knows how to handle persistence-wise any type of T-user, And the user store, by default, uses an application DB context, which is a wrapper for an identity DB context of T-user, which happen to use, at the end, entity framework to do reads and writes against a database. Okay, you can hide and replace whatever is grayed out on the slide and create your own set of classes as long as you expose out of your new class an iUserStore object. So an object that implements iUserStore of T-user. Okay, so if you want to get rid of entity framework, if you want to use a RavenDB, MongoDB, if you want to use an XML file to save data, to retrieve and persist your membership information, you can, as long as you provide an object that implements iUserStore of T-user. And at that point, you can ignore application DB context, identity DB context, and so forth. Works with entity framework, but the store can be replaced to be anything, even RavenDB. And if time allows, I'll be more than happy to show you a user store that uses RavenDB instead of entity framework. But anyway, in case we don't have time, there is an article that I wrote for MSDN magazine about a year ago that just shows that, just discusses how to extend the ASP.NET identity user store mechanism with a persistence engine based on RavenDB and completely ignoring entity framework. That screen now shows essentially the set of tables that are created when you have an ASP.NET identity infrastructure in place. There are a bunch of tables, roles, claims, logins, roles, users, and then some other tools to manipulate the content. Tables here, including the migration history, which is specific of code first, are sort of self-explanatory. Here you will find the list of roles. Here you will find the list of claims for a user, so the extra information that you can capture from the identity checker. So say you connect via Facebook, so it's Facebook responsible for authenticating the user. You can ask, okay, Facebook, the identity checker, to return you extra information you treat as a claim. So tell me the picture, the URL to the picture of the user, tell me the birthday, tell me the address, the email address or the physical address, whatever you need. So claims are essentially attributes you associate to a user, but attributes that can be captured, can be provided only by the identity checker. User logins is, okay, not because you have a user, it means that you must, in general, be able to authenticate that user always in the same way. So today, with the social networks out there, some websites allow users to authenticate providing username and passwords specific for the site. They create an account with the site, or you can authenticate using your social networks accounts, Facebook, Twitter, and whatever. This makes up for the need of a membership infrastructure to essentially store credentials or details useful to authentication for all the different ways supported by the site for users to authenticate. This is what they call a login, a user login. So it's a credential, essentially credentials, okay, each of which points to a different identity checker, which could be my own site if I check myself, username and passwords, but could be Facebook, Twitter, whatever. User roles is which roles a particular user participates in, and then the list of users. Okay, now let's open up Visual Studio. Just create the sample template application they offer in Visual Studio 2013 that shows how to use ASP.NET Identity, I mean, at least as recommended by Microsoft, but it's essentially the way in which it should be used. There are typically 3 points we want to focus on. The configuration, so how to configure the environment so that all binaries are in place. The infrastructure, so the classes we need to create in order to move data around the various parts, so the login page, the edit user profile page, and all the common things we may need to have on a website, the register page, and so forth, and how we actually accomplish the basic tasks of authenticating a user. Okay, let me switch first to Visual Studio. Okay, this is the basic application that I just created from a new app in Visual Studio, so nothing fancy, nothing special, no significant changes made on my end. When the application runs, it offers at the very minimum, register and log in. If I register, it offers me and it complains. Now, it complains, it's native. Now, it wants now a password that has a combination of uppercase and lowercase letters, numbers and underscores. If any of this is missing, it complains. Okay? But this logic is hard-coded in the configuration of the infrastructure. So to change this, you only have to inject in the infrastructure a class that simply knows how to validate the content of a password. It validates the structure of the password. It's called password validator. So it doesn't check whether the password matches what the user entered. It just validates that upon registration of a new user, the password it provides is conform to some security standards that you set through a class you have to inject into the system. Okay, so now that, let me see, foo_1, I register, and thanks God, it now passes, it accepts. Maybe. Okay, and now I'm logged in. Okay, there is a false that displays over there. This is the only extension that I made myself to the standard template from Visual Studio. We'll get to that in just a few seconds. Essentially, it's an attempt to connect user information and roles. Essentially, the false there means that this user is not marked to be a guest of the system. Okay, if I log off and try to check in again, everything works as the ASP foo.com, foo_1. Okay, remember me, log in. Okay, and I'm now back. So the behavior on the surface is exactly what you need, what you expect, and nothing really special takes place. Let me see if I can open up the Server Explorer here to there you go. So these are the tables. We can check that ASP.NET Roles contains just one role. It's called guest. Guest is the ID and guest is the name. This one is, I think, empty. user logins is empty because, yeah, there's no login provider, no key and user ID, nothing special to identify. For example, if I associate a Facebook provider has a login explicitly, I would expect to find here something that identifies Facebook and then information, secrets, and weird strings that can help to set up the configuration for that particular login provider. User roles as an association between users and role ID. I have the user ID that is identified with the GUI ID, which is a guest. The GUI ID is not the GUI ID of the user I just created. And then finally, users. This is the user I just created. ID is generated. So the unique ID of the user is generated by default as a GUID. And if I take this and even manually, I go up here and put this and say, you are a guest. Okay, believe what, if I refresh that page, okay, I log off and log in again. Now, the Boolean string is true because this user now is a guest. Okay, let's go looking into the source code of this sample application. Let me close everything. Now, the first place where we look into is global SX, and in global SX there's nothing to look at. Finally, fantastic. Yeah, something to look at is let me see, where is that? That's not here. Yeah, there is essentially the to use ASP.NET Identity, you need to configure OWIN because the two things go together. You cannot have one without the other. So to configure OWIN, you have to write some code that runs when the application, the web application, starts up. OWIN is just think of OWIN as a sort of bus, maybe a sort of communication handler that sets up, acts as a proxy between your code and the host environment, okay, which is typically IAS, but OWIN neutralizes the physical dependencies on a particular host environment. And this is a huge change. I don't know if it's good or bad, but it's a huge change anyway from the current status, in which essentially ASP.NET works and has been pushed to be working and fast just because of its tight integration with the host environment, and the host environment can only be IAS. So when you hear about in the future ASP.NET will be hosted, could be hosted in Apache or other platforms, well, it's because of OWIN. Without OWIN, without the neat separation between the web application and the host environment, all those futuristic scenarios wouldn't be possible. So OWIN is a proxy, and it's a necessary proxy to use ASP.NET Identity. And you set up OWIN by putting a startup class in the project. And this startup class is marked with the OWIN startup attribute. The OWIN, and you can even put you can also put this directive in the property info file. And the type you indicate here in the OWIN startup attribute is the class that starts up the OWIN infrastructure and defines what has to work and how it has to work in this proxy environment. Okay, configure auth is a method that is created in another file, this one here, that is located in Upstart by default. And well, this file contains, this method, configure auth, contains basically the configuration, okay, of the environment for ASP.NET identity. So we create the application DB context, we create the user manager, we create the sign-in manager, which takes care of the, I call the authentication manager on slides. It's the component that takes care of just signing in and out users. It's the equivalent of forms authentication in ASP.NET, okay? Think of the application sign-in manager as a wrapper around the functionalities, the core functionalities that otherwise are provided by the forms authentication class. And also, yeah, to store details of the authentication, so far we blindly relied on forms authentication. But the forms authentication class in ASP.NET was actually creating a cookie with a fixed name, .aspx-auth, with some fixed content that you could modify to some extent. So the structure of this cookie essentially is a dictionary of claims, except that nobody uses this word before OWIN, okay? But the old-fashioned ASP.NET authentication cookie contains claims about the logged user that for the most part by default are limited to the username. By creating custom principles, by customizing the ASP.NET authentication mechanism, things you can do since the very first day of ASP.NET, creating a custom principle, you can just attach extra information into the cookie and you retrieve that information through the user.identity object that for years we used to populate the interface of ASP.NET apps and pages subject to login and authentication that we created over the years. So what we do now here is we use the cookie authentication. We say, okay, in this application we are using the cookie as the authentication option, but you can use potentially other ways of storing login information. And we say, yes, the authentication type is based on the application cookie. The login path is account/login. So this is the path where the application will be redirected, users will be redirected in case they try to visit a page that requires authentication and they are not authenticated. This is information that we typically were used to put in the webconfig file, in a section of the webconfig file. This is now specified programmatically. And also we have a provider for the cookie that contains authentication information. And, well, we have code-based tools to verify if the cookie is valid or not, or the cookie, if the place where we have stored the current identity of the user logged, if that info is valid or not. So far we just relied on the cookie and the expiration policies of cookies. This is now a larger, more abstract way to do the same and not necessarily relying on cookies of a given format, in a given shape, and with a given name. If you want to use a two-factor sign-in, we enable that up here. A two-factor authentication is when users connect to a website, they try to register to the website, they connect, and then an email or a text message or something else is sent as a second step of the procedure, and this information has to be entered in a second step. So first they type what are considered credentials, then they receive text message or email message, a second part of the credential to type in to prove that, for a stronger form of authentication. The framework provides a mechanism, so endpoints for you to override to process the first and the second step of this authentication process, but you have to enable that, and this is exactly what happens here. Then, if you want to use social authentication, you just use the method use Twitter authentication on the object you receive, the app builder, and you indicate consumer key, consumer secrets, those fancy strings that social networks provide when you create an application for the purpose of using the authentication logic that they contain. Essentially, when you want to use Twitter or Facebook or LinkedIn authentication in an application, the first thing you have to do necessary is going to the social network that you want to use and create an application. So you go to the dev platform of Twitter and create your own application using your own account. So you connect to Twitter, to Facebook as a user. It doesn't have to be your personal account. It could be also a company account, okay? You connect to the social network, create a dev account. Everything is free, for the moment at least. And there you create, under this account, an application. And when you do that, you are given back, typically, an app ID and sort of a password. Now, Facebook calls app ID and app secret. Twitter calls consumer key and consumer secret. But they are essentially two strings that more or less play the role of the username and password to access, essentially, the authentication services of the provider, the social provider of choice. Okay? And you can, as you can see, the ISP identity supports essentially a variety of social login providers, the Microsoft account, Twitter, Facebook, Google, but also LinkedIn, even Instagram. I mean, the Instagram, for example, is not supported here, but all these methods are extension methods that are part of the framework. So you can easily use Instagram authentication and just code inside of that method all the steps, essentially the URLs and the HTTP calls to make to Instagram to make it work. So there is no magic here. It's just storing and configuring under a higher level, easier to use a programming interface, things that anyway happen using the OAuth 2 protocol, and is mostly the same for any social network out there. Okay, so at this point, let's say that we have configured the OWIN infrastructure. Next. There are a bunch of classes that we still need to work with. Okay, we have now the infrastructure set up, but we still need to define the programming interface of what we consider a user for the purpose of this application. So I told you already about the iUser interface, which typically represents the very minimum set of properties any user should have according to the vision of ASP.NET identity authors. There are a couple of classes. One is identity user that is predefined. This is a part of the infrastructure. This base class typically is extended, creating an application user. I would even recommend that instead of application, you use your actual application name. So, my app user. And, well, at the very minimum, you derive from identity user. But you can add here more properties to add more information that you want to associate with a user. And this is a method here, predefined, that essentially knows how to generate an identity for the user of that type. Generating an identity is essentially obtaining a claims identity, and claims identity is, at the end of the day, a more modern version of the identity object we have found for years in ASP.NET attached to the user object. It's the principle, what we otherwise call the principle in today's ASP.NET framework. It's a more modern version. Instead of, typically in classic ASP.NET Authentication, if we want to customize things, we create a custom principle. So we create our own class that implements iPrinciple, and we put there all the information we want to have handy, available, as soon as the user logs in. So typically, okay, when this application is up and there is a user connected, there is, okay, an hello message that most user interfaces display. You don't have to be an ASP.NET super expert to figure out that the code over there comes from a partial view or user control or whatever that contains the hello string and then user.identity.name. In classic ASP.NET, there's not much else. You can know about the currently logged user from within the standard authentication interface. So the user that is currently logged in is characterized by the user object, which has an identity, and the identity only has the name property. So if you want to put here a picture and the avatar of the user, either you use the avatar services, but if you want to have the picture part of your membership system or your membership data, you have to find a way to retrieve the picture path at least and display that up there. There are several ways in which you can do this. You can, for example, run a separate query against some repositories. Okay, this is the user ID, the username gives me the related picture, and then you display the picture. This works, but it's an additional query. If you want instead to just store the path of the picture with the cookie so that it's retrieved and read without making additional calls, it's part of the information associated with the user. Today, in classic ASP.NET, you have to create a custom principle. You have to create an extended identity object. But it's a new class you have to create every time. So for every application, typically, you need to tweak the principal class. So you write it once, more or less it will be the same, okay? But to add an extra property or to drop an existing property, okay, you need to tweak the class itself. And there is no correspondence between the user object that is exposed up here, which is a principal, and the user object you store in the database. So the two things are distinct entities. More, when you create a custom principle, you have to write code in a couple of different places. Not just you have to create the principal class, but you also have to put some code in the global SX, so that when the request begins, when the authentication starts, the content of the cookie is mapped to the principal. It doesn't happen for free, or it happens for free, part of the framework, as long as you use the standard principle. But if you use an extended custom principle, you are responsible yourself for making the copy. And that is a piece of code, okay, standard code, always the same code, but always the same code has to be put manually in global SX. Then, this done, user.identity still returns I principal. So there is no evidence of the custom properties you added. So a cast to the proper principal type is required in order to access programmatically the extra properties. Third aspect to consider when you create a custom principle today with a classic ASP.NET infrastructure, the cookie, the authentication cookie, well, that has to be manually created. You cannot call forms authentication dot sign in, set out we, whatever it is. You have to create the cookie yourself because you want to store in the cookie manually the extra information. And you have to parse back that information in global SX. So, creating a custom principles to add claims to the user that represents the currently logged in user requires some work, nothing special. Probably a lot of thousands of developers all over the world did it successfully for years. So I'm not saying this is critical or undoable or particularly hard. It's a little bit boring. And it's nearly, I haven't found in years a way to automate this process other than reducing to the minimum 3 steps that I just outlined. The claims identity mechanism here is, in the context of a wider and more sophisticated framework, is a way to simplify, because now you have a claims identity. And what you receive is a claims identity object, which is essentially a dictionary with all of the properties you have. So the interface remains the same at the cost of creating a claims identity, which logically maps to creating a custom principle. And the code that you find for free, essentially, define here, the manager create identity async. This code, well, for the most part, doesn't need to be changed. And this parameter here ensures that you are creating, so the code is creating claims, reading directly from the properties of the user object. Okay? You are creating and reading information from the cookie and trying to be a reflection to make the match. So it's magic, okay? It's syntactic sugar on top of the same tasks that otherwise we would call ourselves using the principal mechanism. So again, there are not many ways in which a web environment can work. What Microsoft is trying to do with OWIN and, as far as authentication is concerned, with identity, the ASP.NET Identity API, is just trying to make things simpler for developers to use, and at the same time they take care themselves of a lot of the tasks. But just to make everything to be as simple as possible and as customizable and flexible as possible, they are pushing out so many injection points that are great to have because you can nearly modify whatever aspect you want, it takes just writing a few lines of a class to change the validation logic of a password, or to enable two-factor authentication, or to enable Twitter authentication. But, you know, this comes at the cost of making generally more complicated, even simple tasks. So, I mean, again, it's a trade-off, essentially. But I will get back on the trade-offs of this platform, this framework, at the end of the session. Before that, just let me open up this class, which shows the minimal implementation of application DB context, which inherits from identity DB context of T, where T is application user, and this is essentially the infrastructure, the minimum basic infrastructure for persistence. You probably don't need to change these classes except for adding more properties at the application user level. Okay, this said, the final aspect we want to investigate of identity is how we actually perform sign in and sign out of users. And for this, there is an account controller class, and the account controller class has these two public properties, sign-in manager and user manager. You use the user manager to control, start, and trigger any operation that relates to the user. So create user, get user, find user, change password, these kind of things. Sign-in manager, you use that one for sign-in and sign-out operations. Okay. And look, HTTP context, get OWIN context. So we are essentially extrapolating the information about the object from the HTTP context of the OWIN proxy. And we have a reference to the OWIN proxy, so to the pipeline that, according to the OWIN standards, sits in between the application and the host environment. HTTP context is just a host of this extension method that sits there just to give you know, a programming interface that is familiar, because everybody knows that everything starts from HTTP context, but from HTTP context we actually request the OWIN context, because we are now in the context of this new proxy. Login. Okay, the login, the get of login does nothing special. The post of login is a lot more interesting, because this is what we do. This is where we run, where we end up when the user pushes the button to try to log in. Sign-in manager is invoked, and on this manager we call password sign-in, and we just say, look, this is model, email, password, remember me. Okay? These are the credentials that I take directly from the input model that I receive from the form, the posting form. Okay. Sign in, and additionally I can also use the should lockout parameter, which says, lock out the user account if user failed the login for a fixed number of consecutive attempts. Everything, also this aspect, is fully configurable in the startup.auth class. So if you remember what we had in the membership API, in login we were just calling membership.validate user and providing credentials as we would have read them from the posting HTML forms. Here we do essentially the same, except that the point of contact between our application and the backend system is represented by the sign-in manager, and the method is called password sign-in. Which makes me thinking of, okay, in this case we are attempting to sign in via a password, but maybe in some future we may try to sign in using other methods, not a password, which could be maybe, I don't know, look into the eyes, the fingerprints, or I don't know what else. The method here returns a result that can be of 4 different types. It can be success, in which case we just redirect to the request, the originally requesting URL. It can be logged out, or it can be requires a further verification, or it's a failure. If it's a logged out, return view logged out. And logout is, at this point, a view that you create with that name, fix the name by convention in your views and views account folder. Plain ASP.NET. More interesting if the status is requires verification, because this means that we are in the context of a two-factor authentication process. So, okay, the first step of the authentication of checking the credentials is okay. But now the site requires more. And requires in particular that the user types in a new interface that will be provided a value, a code, a string, something that is sent to the user through different means. Most typically emails or text messages. What the framework offers is redirect to action, send code with a return URL, which is the originally requested URLs where the user should go once the entire process of authentication has successfully completed. Send code is another method you find on the account controller. Of course, it's called send code here. You can change the name is arbitrary. It's just a method on the account controller class. And it gets the user ID, and it also gets the list of providers registered with a proxy that can be used to send the verification code to the user. And typically, you can use your email, the mail server on your web server or an external web server, or you can use if you have a Twilio account, you can use that one to send text messages. But providers that offer this service with an interface compatible with the class must be created and provided, and they are not registered at the moment in this demo application, but you have just the infrastructure ready. Okay, at that point, yeah, it also shows a user interface with a list of providers that have been previously registered, user factor select partners, blah blah blah. And after that, when the user from the send code that probably should be somewhere here. This is the user interface of this sample application for the two-factor authentication provider. You will receive a drop-down list with all registered providers. You pick up the one you like, you push submit, and we are back to send code now as a post. And we call, again, sign in manager, send the two-factor code async. This is the selected provider, and if everything is okay, verify code. We go to the page where we actually enter the code that we receive probably in real time via text messages or emails, and finally verify code. Where is that? Verify code. Okay. Displays a user interface, and when has been verified, if this is okay, we jump up here and are finally redirected to the expected page or the user account is locked out, or some error occurred. Okay? So this is essentially part of the framework, but consider that the account controller class is that you get from this standard default HTML template. Well, this is a piece of code that contains a lot of extra additional complexity just because it attempts to show all the things you can do, you can potentially do with ASP.NET identity. And if you want to, for example, if you want to log in using an external component, in first place, you go here, external login, which is a common interface for whatever login provider you have registered, Facebook, Twitter, and so forth. From there, you trigger the process, sign in via an external provider. You get this triggers the process of displaying the Facebook interface, the Twitter interface. You type in whatever, and then you see again success, logged out, or why not, requires verification. And also you see here what's required if you want to essentially still have users that accept to log in, that decide to log in via Facebook, to provide some extra information to use. Okay, you logged in via Facebook, but please, we need an email address. Type the email address. In some cases, you can get the email address as a claim from the login provider. But to do that, you have to modify this part of the code to ask for a specific claim. Or use the API. Okay, it starts getting a little bit more complicated if you want to get some external claims. Otherwise, from Facebook you can obtain the email address of a user. From Twitter you can't. So if user connects with Twitter, you may want to display external login confirmation where you ask the user to type the email address or the birthday or whatever extra info you couldn't automatically capture from users. So in the end, roles work basically the same way that they work in membership. There's a table, you add elements to a table. The UI for adding roles to a user, that's completely up to you. You can check roles on a user using the familiar isInRole method on the user property, and notice name of roles are case sensitive. Okay, what's the point of this? Why? Oh, okay, before we reason about that, sorry, let me run the final demo that I have here for you, which is essentially this sample application that one day will make it to the wild to help my daughter and kids to measure the quality of their English. It's called The Book is on the Table, which is more or less the way in which Italians pronounce the book is on the table. But anyway, what's interesting here is authentication via Facebook. You cannot, if you put up a website and want kids to use that, no way you provide username and passwords. Okay? You have to provide the social and typically Facebook authentication. But it has to be quick, extremely quick and direct, as is. Click, the page refreshes, I'm in. Log out, I'm out. In, out. That's it. Of course, this works this way because on my computer, I'm connected to Facebook. If I log out of Facebook, then it will go through the classic interface of Facebook. And the same for Twitter and whatever. Now, for this very, very specific form of authentication, honestly, ASP.NET Identity is definitely too much. Absolutely too much. I can achieve the same, okay, specific to Facebook, and probably to be sort of adapted if you want to add also Twitter, but doable. In the real world, probably when you talk about social authentication, even for sites that offer you Twitter, Facebook, LinkedIn, Google, Instagram, it's Facebook for the most part. Twitter. Instagram would work, especially with young people, if that is the target of the site you build, but Facebook is the most obvious thing that works across the spectrum of population. So if Facebook is important, well, with Facebook and Twitter you are close to 99% of social users. So even if you have to kind of duplicate the code, which is not true, but let's assume you have to duplicate the code, we are still talking about a small fraction of the complexity that you put on with ASP.NET Identity. And even if you have to add on top of social and Facebook and Twitter, even some classic credential, okay, it's having a database with a couple of columns, maybe 3-4 columns, okay, custom principles, extra work, but it's standard code that most books, most questions asked on Stack Overflow recommend how you do, and it works. So we are really talking about gaining control over what we really do and understanding what we really do. Go with the code for this Facebook authentication. I have a login controller. So when I click on the Facebook button, I call, on login, I call just the method Facebook. Control M O. Okay? So this is what I have. The Facebook method to start the login process, the Facebook authenticated method to refresh the user interface past a successful authentication and sign out. I'm using here the Facebook C# SDK, NuGet package. You also need a NuGet package for ASP.NET Identity, okay? So NuGet package, Facebook C# SDK. This is the entry point, Facebook client. Client get login URL, new, okay, the client ID. So the code, the Facebook code of the application, that in this case is in my web config, okay? This is information you know when you set up a Facebook application to act as a proxy between the social network and websites. I pass this in, the return URL, the response type, I want it to be code. You find this information in documentation for the Facebook SDK. Display as a pop-up in case the user is not already connected. You want to see a pop-up for login, or you want to be redirected to a page. You can choose which approach you like, and then the scope. You want to gain access on what? Okay, besides the basic username and display name of the user, is there anything more you want? You just put a comma separated string of names in the scope variable, email and published string. okay, the strings you can use here are part of the Facebook documentation. In particular, I'm getting the email address, and I'm gaining access to the public stream, to the wall of the user. So if the user enables me, authenticates, gives consent to this application, I'm already gaining a token at the end of the procedure from Facebook to post to the wall. Okay? So my purpose for the SMIT application is, okay, you go through a sort of a survey to measure the quality, if you can understand what jargon, idiomatic expressions mean, you get a score, and then by pushing a button at the end of the survey, you can publish, okay, the results to Facebook. I'm done as a developer. Once the user gives the consent, at this point, I'm done. And the scope you specify here also influences the message that Facebook displays to users. So look, this application requests permission to read your email address, your authentication details, so username and display name, but also it requires the permission to write on your timeline. So it's up to the user, accept or not. Okay, and once I have the login, so the response of this function is a URL to call on the Facebook website, I just redirect to this URL. And Facebook does its own magic, and okay, and the return URI, which I pass up here, tells Facebook the URL that has to call back past successful authentication. So login is the name, because I'm still in the realm of ASP.NET MVC, login is the name of the controller, Facebook authenticated is the name of the method. Of course, it's a URL, so you can even redirect to yet another website to do past authentication validation. Okay, when back from Facebook, there are a couple of things I have to do, but this code is essentially code that you can copy and paste and reuse, put in a library, in a custom library. So again, from the Facebook Live instance, I parse using OAuth logic, the request URL, so I extract information from the URL that map to OAuth, which is the protocol, the security protocol that most social networks use. I extract information that Facebook sent back to the client. This information is not yet what I need as a developer to log users in, but it's a token, it's a code that has to be exchanged again with another call against Facebook for an access token. And the access token it's a string, a GUID-like string. The access code is what gives me the power of posting. It's the key that enables me to post or read information about the user. So I say, look, this is the code that you provided. Now, please get this code and serve me back. These are my full identity as a custom Facebook application. Gets me back the access token that is saved into this variable. And actually, it's dynamic here because Facebook returns a JSON, and the shape of the JSON depends on the scope I set in the previous call. So it's really hard to figure out the actual type that is being received here. So dynamic is a nice way to, okay, it drops type safety, but it works most of the time. Okay, I save back in a local variable the access token I received from Facebook, and then, that's another piece of custom code, I save the access token somewhere. In particular, I save it to a cookie. It's my own cookie. So now, after that, I'm still waiting for, okay, I save the access token, and once I have the access token, I can start querying Facebook for whatever the user gave me permission to check. I can get me here indicates the current account. I can read first name, last name, email, whatever I want. Okay? And then now the user object is the entity that contains information about the Facebook user. Okay, next is how can I make this information persistent? Persistent to ASP.NET. What I can do here is creating essentially a cookie. So I create a cookie using forms authentication. So I'm not using OWIN here. Just plain forms authentication. The username for the display purposes is first and last name of the Facebook account. I'm not using here custom principles because I just want to limit that, but I can give you, if you're interested, I can give you the link to an application that's it's on Codeplex, where I also use a picture and create a custom principle. Okay, then I append the cookie and redirect that. Access token save. This is something like that. I create another custom cookie and store the token into this custom cookie. So I end up having two cookies. One is the classic ASP.NET authentication cookie. The other one is my custom cookie where I store for a day or for the duration that you like the access token for the user. Meaning that when the user gets back, I'm still having an access token to start posting to Facebook, if that's the case, right away, with no need of further authentication. I could, of course, put the two things together. I can avoid the Facebook-specific cookie and put that information with the username and password in the authentication cookie, but that requires, for read it back, but also for creating, well, but especially for reading it back, requires a custom principle. Or the complexity of ASP.NET identity, where all this stuff, reading, email, whatever, can be resolved in terms of claims, in terms of the specific API, but at the cost of a significantly more complex infrastructure. Complex means that you can probably cut it short, cut it down, but the drama is figure out understanding what you don't need. And the documentation is not, honestly, really great. So, in summary, what's the point of ASP.NET identity? They present, this is a screenshot from the Microsoft ASP.NET website. The identity system is designed to replace the previous membership and single membership systems. It includes profile support, OAuth integration, work with OWIN, included in the templates shipped with Visual Studio 2013, all true. But includes support for this, means that the whole thing is, well, probably, I mean, it's a personal opinion now, probably contains too much and is ridiculously complex for simple things. Especially if working with forms authentication is not a big deal. Because we are receiving the message that working with the system web and forms authentication is the worst you can do because it kills the scalability of your app, blah, 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 blah. Now, I just wrote an article for a Redgate, a Simple Talk newsletter, and if you want to, you can check it out. The title is Premature Scalability is the New Root of All Evil. Now, I can agree that if you're looking for extreme speed, scalability, this or that, the architecture of OWIN is probably cleaner for sure. It's for sure cleaner. It decouples the web application from the host environment, I'm not sure this means more scalability. Maybe I'm not an expert enough in, I never worked probably enough in the enterprise environment, large-scale enterprise apps. So probably I'm saying something totally silly. I think that for what people really need today is websites that work fast. Fast, it's a different thing than scalable. Fast is fast, and to write fast websites, you need caching, essentially. You need to ensure that most common operations take place as quick as possible. It's a matter of performance. It's a matter of getting fast response. Scalability is a different thing, related to performance, but it's different. It says that when the number of requests and users grow, the system doesn't have to doesn't have to die, but has to resist, and probably, resist well. But the scalability is either for, instantaneous peaks or growth over time. But, instantaneous peak, how many websites are like that? There are a few, but unless you are in that context and you face a specific problem, Systems that are expected to grow over time, it means that in a couple of years, when the growing number of users has stabilized, if the system doesn't support that well, you rewrite the system, or you reconfigure the system, or you restructure the system. It looks to me that with the excuse of the cloud, we can probably think that we can write a system today, and then just pushing a button, plus, starting new web roles in a cloud console, we can make it scale as much as possible for the foreseeable future. Maybe this is what Microsoft and other vendors dream, but I'm not sure this is really what architects and developers and companies really need. Because you need to have the website to stay responsive regardless of the number of users. It's desirable that the number of users grows over time, but that means more success. And if it means more success, it means that you can likely invest some extra money to power the hardware, to restructure and go to the cloud, to do maybe a different infrastructure for storage. But this means considering polyglot persistence, for example. It means considering distributed caching. It means considering, yes, the cloud, why not? It means considering different strategies, like even sourcing in terms of the architecture. Consider that Facebook was not built in a day, Twitter was not built in a day, but they grew up to the size, the humongous size they have today. An extremely popular website like Stack Overflow, it's a plain, stupid ASP.NET MVC application. It uses nothing more than output caching, and I think they use Ncache, or one of the most commonplace distributed caching systems, and a SQL Server database. Okay, they have a significant server infrastructure, of course, but they use caching ahead ahead caching. So NGX, Varnish, one of those products. So they use various levels of caching. I think there's an article. So this is public domain, what I'm saying. There's an article. It's an Italian guy who works for Stack Overflow. He lives in the UK, here in London. And he says that they use probably 4 different layers of caching, but we're talking about Stack Overflow. So unless you have a site with more and more users than a social network like Stack Overflow, okay, so in my opinion, ASP.NET Identity is a good thing to be there. It's good for Microsoft to have it. I'm not sure it's good for developers to use it. For what that matters, I'm not using that. And I don't plan to use ASP.NET Identity in the near future unless maybe I need something like 2 forms authentication. But even if one day I happen to use 2 forms authentication, it's chaining together a couple of redirects. Okay, it's just chaining two redirects. It's not a huge amount of work. And maybe it's my attitude of an old-fashioned 50 shades of gray, a gray hair on the head. But my attitude is that I really, start feeling uncomfortable when I see too many packages, too many DLLs to be dropped. So it's a matter of trade-off. And I think last year I had a session similar on ASP.NET Identity here, and over 12 months, my perspective on ASP.NET Identity changed quite significantly. I was, well, it's interesting. A year ago, it's, I'm not going to use it unless something special happens. This is my position of today. Thank you very much for your time. Welcome everybody again. Also, welcome to all the people who joined in the last couple of seconds. My name is Dino Esposito. I'm here today to talk about ASP.NET Identity and tools and frameworks and approaches you can find under the umbrella of ASP.NET to implement social authentication, classic Facebook, Twitter, LinkedIn, and so forth. There is a clear transition that is taking place in the ASP.NET space towards a new framework. I have no idea, honestly, when this transition will end. It's started, however. We expect Microsoft to ship probably in April, May, I don't know. Summertime anyway. Version 1, I was told that there should be probably an RC coming out today of Visual Studio 2015 and related frameworks. Anyway, we are really close to some big drops from Microsoft, and regardless of the quality, okay, that we find in Visual Studio 2015, ASP.NET 5, vNext, Linux support, core.NET framework, and so forth, there is a trend within Microsoft to get rid of a few things of the past. And the few things of the past, as far as the web is concerned, are IIS and the old infrastructure, IIS-based, okay, for ASP.NET. We live in a world that changes frequently at a pace that every 5 or 6 years, okay, let's even every decade, every 10 years, completely, moves things around, and what was right becomes wrong, and what was wrong becomes right. You can remember maybe when, not that many years ago, I think it was around 2007, 2008, maybe 2006, Microsoft pushed out IIS 7, and was all about, all the marketing effort were focused in telling the people how well they did in integrating the IIS runtime with the ASP.NET runtime. There's still a terminology, integrated pipeline, which still we face today when we try to configure an IIS web server. Wow, it's great, it's fantastic, it offers you great performance just because the ASP.NET runtime and the IIS runtime are the same thing. And which are alternatives in case you don't strictly need it. And then how we can, in alternative, outside using ASP.NET Identity, how we can do social authentication via Facebook, Twitter, and similar social networks. In ASP.NET, the whole theme of membership has been a long, long story that probably different teams in Microsoft tried to simplify and cut short at different times, but probably nobody successfully. And I just tweeted before starting the session that if I think of authentication today, I believe that it's nearly impossible to build a framework that is universal, supports all possible features of today and tomorrow, so allows you to define the user in whatever way, so with whatever combination of properties you may think of, and with a lot of additional features like two-factor authentication that some sites require and some other may happily ignore. So a universal framework, if it really has to provide support for whatever you can think of today and tomorrow, ends up being significantly complex, and I would say ridiculously complex for doing basic things. So the trade-off, and it's hard to find the right compromise, the right measure, especially if you are a vendor of frameworks, to understand where you have to stop to keep all possible customers, prospective customers especially, happy. So this is the drama, the human drama that we experience, that ASP.NET Identity experiences. It's growing complex every day, and because it gets complex and complex every day, doing simple things that probably the majority of people need to do becomes harder and harder and boring and annoying every day. But this is not a new story. When Microsoft first released the membership framework in the first version of ASP.NET, the classic ASP.NET membership, we could already see some 10 years ago the same problems we can spot today, except that 10 years ago the problems were probably the same in number but smaller in terms of absolute size. So we still had, with a classic membership system, auto-created SQL Server table of these interfaces at the same level of Windows services, console applications, non-Microsoft web servers, and any sort of application of today and tomorrow. Just to say, just to give you a concrete example of what I mean, what we are trying to, what Microsoft is trying to achieve, which was not available for years, for decades, I would say. It was around 2000, so 15 years ago. A company called me to help them building a local web server. It was a different age, so the purpose this company had in 2000 is something that today would make us just laugh, okay? But at the time it was cutting edge, and they needed a super guru to help them out. They wanted to put on a CD-ROM essentially the website. They were a media company. They had a bunch of websites with a lot of information, financial information specifically. They just wanted to put everything as it was a website on a CD-ROM. And they, to save time, they just wanted to just take the ASP, active server pages, from the website, put on a CD-ROM, and have the CD-ROM work like a website. So the user had to put the CD-ROM in the computer, and automatically they wanted to see some browser to open up and for the user to navigate locally with no internet connection, and the world was the CD-ROM. The problem was just creating a local application that could work like IIS. It was not that hard. We did it, and it was kind of hard because we had to, simulate a lot of things. We had to essentially find a way to inject a scripting engine into the the binary engine we were building to process requests. We simulated that. I guess that today, with an open web interface like OWin, the whole things we did 15 years ago with a lot of effort would come probably much easier. Okay, now, this talk, will you hear about an introduction, role, purposes, motivation, technical details of ASP.NET Identity, the role it plays in the real world. I'm not completely sure everybody needs it. They work closely together. And today, they are telling us the opposite. What is wrong with ASP.NET is that it's too tightly coupled to IIS. We need to break this dependency. And they introduced OWIN, the Open Web Interface, which is a good thing, but serves different purposes. So the point that is trying to, that is critical in my vision of the world, and also in relevance and in connection to this talk, is the fundamental question that, as an architect, as even a an IT manager, has the professional figure responsible for choosing actual technologies for writing code and strategies for doing certain core things in web development, like membership and authentication. The question is, how important is for me have a dependency on IIS? Will I be porting my code in other platforms one day, my server code, my server infrastructure? If I work fine, nicely with IIS today, if I don't feel special concerns, whether performance, whether scalability, with the status quo, with what exists today, most of the things, ASP.NET Identity, OWIN, can be happily ignored, even though OWIN per se is just yet another abstraction layer, more general, that can encapsulate the current IIS as a special case. So in OWIN, Katana, all those keywords that you may have heard and you will hear more and more and more about in the coming days, as soon as new releases of ASP.NET see the light, are things that don't touch directly the way in which we do things. We still need to do authentication, we still need to do authorization, we still need to do membership, we still need to process requests coming via HTTP our way. It's middleware. It's the way in which the runtime, the web runtime, works. And what they're trying to do is making the existing infrastructure, which is essentially a pipeline of steps, begin request up to end request, with session authentication, with cookie management, with output caching, with authorization and authentication. All these steps in the pipeline will be given a common standard interface, and this essentially makes IIS one possible implementing and containing information for users, roles and associations between users and roles. We also had a bunch of server controls for common membership tasks, like the login, change password, reset password, and they made a good job by putting the membership system in the context of a provider-based architecture, meaning that they gave us a base class and told us, okay, this is what we provide out of the box. And if you use our framework out of the box, you must use a bunch of tables with the schema we decided. If you want to change the validation rules, if you want to hash passwords, for example, or if you want to put more logic that controls and makes the detection process of a password more complicated, so detect that the password has numbers and letters and underscores. If you want to, customize some aspects, well, you can do that at the cost of overriding the entire system, creating your own membership provider. It worked. It worked. It definitely worked. And it was a nice point because, well, before ASP.NET, a lot of websites were already facing the world, and those websites were built without the ASP.NET membership system. So they had their own logic for validation of users. They had their own databases. But yet, because of this non-standard structure, those custom membership systems could not be used and attached to server controls, which were giving all developers a boost in terms of speed of development, because a login page was as simple as just dropping a server control in the page, and everything else was being taken care of by the infrastructure. But with a custom provider, membership provider, you could wrap up your existing infrastructure, your existing database tables, and the standard interface, the custom provider, allowed your existing infrastructure to be connected to the facilities in Visual Studio and server controls. It was not a bad thing. It was working, and it was, well, complex, but not so complex to scare people. Anything wrong? Just one thing was wrong. And in particular, the fact that the interface of the provider was not really respectful of the I in the SOLID acronym. The SOLID